Now we shall be moving towards the liquids. So as you know, popularly that we are just moving towards the about the liquids. As you know that liquids have definite shape. They don't have definite shape. Okay. So, and they are fluids. They are movable. Okay. We can means simply the particles of liquids are not fixed. They are continuously moving. They can move from one position to another position. Okay. So we'll say that liquids have fluidity and they can easily flow. They are not rigid. They are not rigid. Okay. And we'll simply say that they have a definite uh, volume. Why they have definite volume? Just because the particles are having a space between them, but not having much space that they can be further compressed. So liquid are compressible. Low in compressibility means, so if something is compressible, then its volume can be changed under the action of pressure. But at normal condition, liquids have a space, but they do not. We can simply say that they have fixed volume. Okay, under the action of the force, they are compressible, so their volume can also be decreased. But okay, so low compressibility and means they have indicating that they have fixed volume, almost fixed volume, fixed volume.
Sir, what does rigid means?
What is
What does rigid means?
rigid? Rigid means hard. Okay, they are not hard. They're not very hard. For example, if you have water, you can easily means okay. So they are not rigid like the solids are. So you can easily pass your hand in the water but kept in the bucket. Okay, so that is not rigid. They have definite volume. Definite means fixed. Fixed volume. Volume means you understood the volume. What do you mean by volume? Volume means the tendency of a matter to occupy some space. Okay. So we can say that when something is occupying space, it means it is having some volume. So that space which something can occupy is called its volume. So fixed volume means that it's whether you have a bottle, like you have 1 liter of water. Okay. Will you be able to pour that 1 liter of water in half liter of a bottle? The whole 1 liter of water in half liter 500 ml bottle. Is it possible? No. You will have one
No.
half liter of water in the bottle. Otherwise it will overflow. Okay. So same, can you fill the whole bottle of 500 ml from 500 ml water bottle, a 1 liter bottle, 1 liter water bottle? Means you have 500 water, okay, in a bottle A, and you have another bottle B, which is of 1 liter. So if you pour that 500 ml water in 1 liter of that water bottle, is it possible that 1 liter of water bottle get filled completely? No, it will not get filled. Why? Because 500 ml of water will have 500 volume. So it cannot be, it can be refilled in, or it can, if you are just filling it into another bottle, that should also have the same volume, that is of 500 ml. If it is 1 liter, then it will not fill it completely. If it is 250 ml, then it will add some water. Uh, okay, so same thing happens because of this, because they have different volume. But if I'm talking, to the gases, so like you have seen the lighters. Let me show you. So this is the lighter which is having a gas. Okay, and you all have seen this lighter probably. You all have seen this one. So this lighter is filled with gas. This is a liquid gas. Okay, but you see that it is the gas will keep on coming out, even though if the LPG is almost nil, because it is always filling the containers. And you have seen the cylinder in your home. You have seen the cylinder, gas cylinder. So in this gas cylinder that you have, even when so you all have seen this type of cylinder in your home. That always carries 14.2 liter of gas. Okay, but you are continuously using it from this nozzle, and if gas is getting means you are continuously using the gas, so the gas contained in the cylinder or present in the cylinder, it is day by day decreasing. Okay, the amount of that gas is decreasing because you're utilizing that gas. But is unless and until the whole gas get empty in the cylinder, we keep on using it. Okay, we used to keep it. What does it indicate? That gas is, you are using it, you are removing the gas from it, still it is keeping the container completely filled. You are removing it, then still it is carrying, it is completely filled. So it means that gases don't have fixed volume. You can fill 500 ml of gas in the whole 15 liter of container, and you can put the same 500 ml gas in the 1 liter of cylinder, in the 2 liter of cylinder, in the 5 liter of cylinder, in the 10 liter of cylinder, it will completely fill it. So it is not like the water. If you are having 1 liter of water, it will completely fill the 1 liter water bottle. But if you have 500 ml of liquid or gas, and 500 ml of gas can fill the whole means 500 ml of gas will completely fill the 1 liter of container, can fill these 2 liter cylinder, which is having capacity of 2 liter. It can completely fill the 5 liter of cylinder. That is, if this gas have 14.2 liter of gas, we usually have in our home, the 14.2 liter of gas comes. Okay, 14.2 liter. But when even that when it even though 500 grams instead of 14.2 kg, if we have 0.5 kg gas left in the cylinder, we can still use it. So why this gas is coming out with when it is having very low amount in this one? Why it is coming against the gravity? Because the particles of the gases have very high kinetic energy, and they used to be in random motion. So that's why. Okay, that's why they always keep on moving and will keep the container completely filled. So this is the reason. Moving to the questions here is very simple. So, liquids, note it down, please, this one, that liquids have fluidity. They are not rigid, low compressibility, low definite shape, and boundaries they take the shape of the vessels.
I have a question. My friends, like, I was absent for a few days because I was not sick in school, and then my friends were telling me that ma'am completed sublimation of camphor. So what is that?
Sublimation is changing the states of matters when the solid changes directly into gas without going into the liquid state. And that we're going to study after this one. These states of matter. The next topic will be the change in states of matter. And then we're going to study that one. Okay. Don't worry. Yes, Abdullah, are you there in the class? And Tanisha. Tanisha and
Yes,
Abdullah, please
sir.
turn on your
Yes, sir.
camera. Turn on your camera. So you're done? Up to here, you have to note it down. Done? So much.
Yes, sir.
Okay, then the next question is that why diffusion is higher in liquid than in solids? Why diffusion is higher in liquid than solids? Why do we say that diffusion is faster in liquids than solids? Why? Can anybody guess the answer?
So
Because
because in liquids, like, the particles of liquids have more space in between them than the particles of solids, as they're closely packed. So if diffusion, diffusion means like particles of uh different matters, mixing together. So like, in liquids, as there's like space between the particles can go inside the space more easily than in the particles of solid. So that's why I think.
Okay. Well, consider you means this is a nice try. You just try to, but thoda sa I will just going to help it, but it's okay. Very good. Next is yes, anyone? Tanisha, you able to answer this question? No, but diffusion is faster in liquids.
Oh, so see, the answer is same, like
The
you
answer
said.
is same. Same is okay. What is that answer? What does she answers?
That yeah, that the liquids have more space between them, so it is easier for the feeding.
Okay, yes, you Javeria. Javeria. Yes.
liquid molecules are more freely packed than solid molecules.
Liquid molecules are more freely packed, more freely. Yeah, they are free to move. Yes, you Chakrika.
Liquids have more kinetic energy than solid particles.
Yeah, simple. We have to do this one because the diffusion is possible when there is some particles are going to go when they are moving at faster rates. Okay, so it is also one of the more appropriate answer. Okay, they are having a space. Yes, they are also having a space. This is one also we can say that. But diffusion and dilute and dissolution are the two different things. When you are dissolving something, okay, uh, then it is going into the space between them. But in diffusion, it is not necessary that it is going into the space between them. It is intermixing. Mixing means, like for example, if you add potassium permanganate into the KMnO4, if you are dissolving KMnO4 uh, in the water, then it is showing purple color, and that purple color is if this that purple color is visible to you, that it means that it is not going into that intermolecular space. क्योंकि अगर वो intermolecular space में गया तो फिर purple color will not be appear. Something like for example, if something you are dissolving in water, if it is having different color, But if you dissolve it, it color disappear, it means it goes into the intermolecular space. So if you have white color substance, if you have purple color substance, if you dissolve that one and that color disappear, it means it goes into the intermolecular space. Okay, otherwise it is not. Okay, after some time it will settle down or it will form a colloidal solution that we're going to study in the next chapter. Two solution colloidal solutions. Okay, so what I'm saying here is that when the particles are moving, because of that kinetic energy, particles are moving in liquid, the particles can move. So the rearrangement is possible. Like for example, if I'm saying that like if I'm making this one for your better understanding, like for example, okay, like if I'm having uh this a beaker and I have a red balls here, red balls, okay, and then I'm having green balls. Okay, let me try here. Okay, because it is getting stuck here. So if I'm having red balls, some red balls and some green balls or blue balls, whatever it is. Okay. So I'm having red balls and I place green balls over it. And I place green or yellow or any other kinds of balls. So I am placing green balls here. So when that green ball will merge in the if I ask you to that merge them, so how it is possible? So if I am saying that these balls are packed, means these balls are having means I just pasted all these balls with the help of glue. So these balls will remain in a line, will remain in a line, and these red balls are also are also I have pasted that one, and these ball cannot move. So if you even if you do the random motion between them, they will not mixed up because they are pasted. They cannot leave their space. But if I'm saying that these balls are not pasted with the glue, okay, these are free, but you have kept it in the layer and then you randomly squash them, or you can say that. So what you will see that after some time when you do one or two times this one, okay, when you so you will find that you will notice that the green ball and red balls will get mixed. Okay. So when these balls are free to move, then okay, अगर ये बॉल मूव कर सकती है फ्रीली तभी इनका इनके अंदर ऐसे ये डिफ्यूज कर सकती है, तो दिस इज कॉल्ड डिफ्यूजन. ओके, ये डिफ्यूज करके, तो ये कब पॉसिबल है जब पार्टिकल्स आर फ्री टू मूव. If they are tightly packed, they are not free to move, then it will be slower. So in solid, the particles are tightly packed, and this is the one of the reason that the diffusion is slower in that one. While in liquid, some particles are free to move and they can easily uh, help in random arrangements. Okay, so that so rearrangement is possible in liquids. So rearrangement is possible when the particles are movable. So please note it down this one. Done? Done this
Yes.
one? Everyone? So have you noted this one that why diffusion is slower in liquids than this one? Noted everyone?
Yes, sir.
Yes, okay. So let's move to the next portion about the gases. Okay, down. Gases have fluidity, they are highly compressible. Compressible means they have, why I'm saying something is compressible. So what do you mean by the word compressibility? The compressibility means simply the link that the particles have large space between them and they can come closer to each other. Okay, and under the action of force, they can
Apply
come closer.
pressure.
Yeah, they can come closer. So we can simply say this one that gases have high fluidity, they are highly compressible. And when you are compressing something, what does it mean? When you are compressing something, what does it mean? It means that it does not have fixed volume. And movability, अगर कहीं भी movability है यानी particle एक जगह से दूसरी जगह जा सकता है, it is possible that a particle can move from one position to another position, then it will not have any fixed shape. Because here the rearrangement is possible. Fixed shape कब हो सकती है? जब particles are not free to move, and that occurs in solids. Okay, so solids have only fixed shape. Other states of matter like gas and liquid don't have fixed shape. And highly compressibility means indicating no definite volume. Jagrik, are you there?
Yes, sir. Sir, I just can't on my video for 2 minutes, so.
This one, please. Done. Abdullah, are you writing? Your only head is visible to me, not the face. The whole face should be visible to me, na? Done. Okay. Everyone done? Should I move forward?
You can have 2 more minutes.
Done. Asking a simple questions to you. That why, if I'm saying that you're gonna have means you are having any vehicle. Okay, so in that vehicle, will you in this during the summer days? Okay, like for example, normal pressure. of in a tire is 40 psi. So should we use more than 40 or less than 40 in the summers?
Sir, could you repeat what you said? I couldn't hear your voice properly.
I'm saying that in normal vehicle, we should use 40 psi pressure. There is a unit measuring scale 40 psi. But during the summer season, should I use more than 40 psi or should less than 40 psi? मतलब कहने का मतलब ये है कि गर्मियों में ज्यादा हवा भरवानी चाहिए टायर के अंदर या कम हवा भरवानी चाहिए समर सीजन में ज्यादा हवा कि कम हवा
Less.
More.
Less.
लेस व्हाई
Because the particles might expand due to the heat and burst.
yeah because you know that when we are having in the summers actually the black tires are also black in color and because of that black color and the frictional force tire becomes much hotter. Okay, the temperature keep on increasing. Okay, so the gas that is present in the tire, it is start vibrating at faster rate because its kinetic energy increases because of high temperature. And what is pressure actually? Pressure is that if the particles are hitting with particular speed, okay, on a wall of the container, then they exert a force that we call it pressure. The force exerted by moving particle that or hitting particles on the wall of the container, we called it indirectly with that is called pressure. Okay. So when we are having means that during the daytime if the temperature increases, then what would happen? It will keep on striking it at faster rate. समझ आया? तो अगर ये तेज तेज स्पीड से इसको हिट करेगा तो फिर क्या होगा बोलो? हम्म? अगर ये उसको तेज तेज स्पीड से हिट करेगा तो क्या होगा? टायर बढ़ जाएगा क्योंकि प्रेशर बढ़ जाएगा प्रेशर. So simply in the summer season we should not use means we should जो भी लेवल है 40 का लेवल है तो उससे कम हो बढ़ानी चाहिए. और अगर सर्दियां हैं तो सर्दियों में काइनेटिक एनर्जी कम हो जाती है पार्टिकल की दे डोंट स्ट्राइक एट फास्टर रेट तो उसमें प्रेशर कम हो जाता है तो उसमें हमें सर्दियों में हमें प्रेशर ज्यादा रखना चाहिए. ओके गॉट इट समझ आया. तो इन
Yes,
दिस
sir.
इन द समर in the summer season we should keep the less pressure than the given value because due to kinetic energy due to heat the kinetic energy of the gas particle present in the air sorry present in the tire start hitting at faster rate on the wall of the tire and because of that the tire may burst. Okay, the pressure will increase and the tire may burst. So please note it down this question. When you're done, please let me know. Value done, please let me know, okay?
So what is molecular motion?
What is molecular motion? Molecular motion means movement of the particle. Molecules means move particle. Okay, and that molecular motion means particle motion.
Means
Reducing molecular motion means reducing particle motions. It's the particle of gases. Okay, indirectly it is talking about. that.
yes.
Done, sir.
So
So let's see.
Sorry, just 1 minute. I was on the last line.
Done?
Yes, sir.
The next topic is the change in states of matter. So how, what are the factors that are responsible when we change the states of matter? So let's discuss that one by one. Okay. Change in states of matter. Now, we shall be moving to the next part, that is change in states of matter. That when we are changing the states of matter, what happens? Okay, what are the factors that are affected and how can we change the states of matter by increasing temperature, by decreasing pressure, or by increasing. Okay, so that's we're going to discuss in this topic in this lecture. That is just a minute, that is going to be. First of all, that is the boiling is the temperature in which the liquid changes. Liquid are going to change. Okay, their states, we can say that liquids get converted into gas, and the pressure should be 1 atmospheric pressure. Okay, that we called it boiling point. Okay, so what is boiling point? So note it down. The temperature at which, first of all, we should know that when we are changing the states of matter, what is boiling point, what is melting point. So note it down. The boiling point, the temperature at which the liquid changes to gas at 1 atm. 1 atm means 1 atmospheric pressure. 1 atmospheric pressure. Done. So why? What do you mean by this 1 atmospheric pressure? Why I was specifying this 1 atmospheric pressure? It means that if we change this one, there can be some different temperature also. First note it down, and I'm going to explain this. So if I'm saying that 1 atmospheric pressure, what do you mean by this? So let me explain you this one in detail without wasting the time. Okay, look at this please. What I want to say here is this, that one. Just everyone please turn on the camera. Okay, don't make it turn off, turn on again and again. Okay, so what I'm saying here is this one, that for example, if you are having, if you are burning, if you are having a container, you kept it on the, okay, this is the container and you are just heating it. I've just kept it on the burner. Okay, and you are heating it. Okay, you are heating it. And the water is present in this one. Water is present in this one. So you notice that the water is start converting into gas at 100 degrees Celsius. At 100 degrees Celsius. Okay.
Yes,
Now
sir.
coming to the point here is that can water boils? Is it possible to boil water below 100 degrees Celsius? Is it
No, sir.
possible?
No.
So what actually happening is there that it is
Eh,
the that you know that boiling is something that when you are converting liquid into gas. So may I know the reason that why the upper surface particle that are the topmost layer of particles, okay, that are at the top of the liquid or of this container, why they are not escaping? They can easily escape. Why they do require large amount of kinetic energy? Why they require large amount of heat at 100 degrees Celsius heat to convert into gas? Why can't they be easy? They can easily be removed. The reason behind is very simple, because there is an atmospheric pressure that is exerting over the surface. The pressure due to atmosphere, that is air, the weight of the air above this container, the whole air that is above this container, that has particular weight, and that we call it 1 atmospheric pressure. That pressure is called 1 atmospheric pressure. So what actually boiling is? Boiling is that these particles want to go. These particles wants to leave the surface. Okay, but it is not. They are not allowing it. The atmospheric pressure is not allowing it. So it want to lift it up. The water want to leave. The water particles want to leave, but the atmospheric pressure is pressing it. It is not allowing it to left the surface. उसे जाने नहीं दे रहा.
So when it reaches a certain temperature, it can.
So yeah, when it reaches 100 degrees Celsius temperature, then the the pressure exerted by these particles, but they still have kinetic energy now, so they can easily overcome this atmospheric pressure. Means that the pressure of the liquid is called vapor pressure. Vapor pressure.
So when it has high kinetic energy, it can overcome the atmospheric pressure.
Yeah. When vapor pressure of a liquid, the temperature at which the vapor pressure of liquid become equals to atmospheric pressure. Atmospheric pressure. We called it boiling temperature. So what is boiling temperature for water? The temperature at which the vapor pressure of this liquid that you want to vaporize, okay? The temperature at which the liquids or the vapor pressure of liquid become equal to the atmospheric pressure. We called it vapor pressure. Sorry, we called it boiling temperature. So that's why in the definition it is at 1 atmospheric pressure. Okay, we are just specifying the conditions of the pressure. So is it possible to boil the water at low temperature? Yes, it is possible. If we have a vacuum, like for example, if we have a jar which is kept in vacuum, imagine that this is a jar. Okay. And this jar is kept in a chamber which is airtight, and we can remove the air from it. Okay, we can remove this air from it, and here just by from the vacuum pump, with the help of vacuum pump. So when we are removing this one with the above vacuum pump, okay, so there will be no the air pressure that we are exerting, the air is exerting. If we remove that air, there will be no pressure. So it can easily boil at even at 30 degrees Celsius, at 40 degrees Celsius, at 20 degrees Celsius, water can boil. Water can leave the surface. Okay. So let me show you this one, that how does water can easily boil at low temperatures, so that you can understand it more betterly. That it is possible, but we have specified a condition. If you are saying 1 atmospheric pressure, you have to keep the pressure 1 atmosphere. Then you have to apply the 100-degree temperature. Otherwise, if you are decreasing the pressure, then it can boil at low temperature also. If you vacuum it, if you lower the vapor pressure, then you can boil it at low temperature.
So,
Yeah.
uh, so the steam which comes out when you boil the water, is that considered as the water molecules
Yeah,
in the
that will be
form of
the
gas?
yeah, they will be water molecule. But if you are boiling it by heating it, okay, that would be the steam, that will be the hot steam. But water can be converted into vapor. If you are doing vacuum boiling, then that steam may not be heat. Okay, वो गर्म नहीं भी हो सकती, लेकिन steam तो होगी. Okay,
You say it
so
in
you didn't understand? You understood?
Can you
समझ
say
आया?
it in
Okay. What I'm saying here is that when you are boiling water, okay, in the open air with or in the atmospheric pressure, no vacuum is done, then that vapor will be hot and having the temperature of 100 degrees Celsius. But if you are doing vacuum boiling, then that vapor will be cold means that is not going to have 100 temperature, okay? Because that in the vacuum boiling it is done lower than, it might be at 45 degrees Celsius, it might be at 30 degrees Celsius, it might be 20 degrees Celsius, so it is possible. So here we're just trying to show you the experiment by this person who is doing the vacuum boiling. So
Sir,
this
I have a question. What if the atmospheric pressure is different?
so if you increase the atmospheric pressure, then it will boil at more temperature. It will take more than 100 degrees Celsius. If you decrease the temperature, then it will boil at low temperature. So he's doing the vacuum boiling, you can check it. Okay, and now he's removing the air from it. So he is not boiling it, but actually this will start boiling. So the water will start boiling. So you can check it. He is not heating it temperature, but he's just removing the atmospheric pressure. Okay, and then you see that water is boiling. It is coming. So that is only possible when you okay. That is only possible when you do the vacuum boiling. Let me show you this one also by some other videos in detail, but that is a small video. So you can check this one also here. This is also that he just put this one in the chamber and then he start doing vacuum boiling. He's removing the air that is over this jar. Then this water will start boiling without heating, even without heating. So can you give me an application that where do we use vacuum boiling? Where do we use vacuum boiling? That you see that the vapor it just means these are the water vapors that uh, are surrounding the that is here, okay, in the chamber of this. So can you give me an example that where it is used in vacuum boiling, कोई एग्जांपल्स के कहाँ पे हम लोग यूज कर सकते हैं। ऐसा होता है कि कई बार ऐसा होता है कि हम लोग को ना फ्रिक्शनल डिस्टिलेशन करके ना प्रोडक्ट को बाहर निकालना होता है। ओके, आर यू गेटिंग माय पॉइंट? सो मान लेते हैं कि देयर आर टू मिसेबल लिक्विड्स दैट आर completely mixed liquids, they are liquids and they are completely mixed and we want to separate them. This is the liquid A. Okay, this is the liquid A, which boils at whose boiling temperature is like 450 degrees Celsius. 450 degrees Celsius is very good, very big temperature. Okay, and there is another substance which is mixed inside it and whose boiling temperature is, let's suppose, 500 degrees Celsius. It is another liquid that is mixed here. So what we do here is that if we, let's suppose, if we want to separate this mixture from this mixture, means this substance A, which has 4 degrees Celsius or 450 degrees Celsius, and we will want to separate them. But we know that if we heat this to 450 degrees Celsius temperature, then our B substance will get खराब हो जाएगा। मतलब it will get disintegrate, it can convert into some other product सब, क्योंकि आपने तो सिर्फ यही पढ़ा है ना अभी कि वाटर को बॉइल कर दें 100 डिग्री सेल्सियस पर। कुछ प्रोडक्ट ऐसे होते हैं जिसको हीट करने पर वो डिसइंटीग्रेट कर जाते हैं, वो दूसरे कंपाउंड में बदल जाएंगे या टूट जाएंगे या कुछ और हो जाएगा। so they can be a chemical reaction that is the 500 degree Celsius. So even if you heat, इसको अलग करने के लिए अगर आपने दोनों के मिक्सचर को 500 डिग्री सेल्सियस टेम्परेचर किया तो फिर ये बी जो सब्सटेंस है वो खराब हो सकता है अपनी हीट पर। तो हम लोग क्या करेंगे, वी विल डू दी वैक्यूम बॉइलिंग। समझ आए? तो हम लोग क्या करेंगे, वैक्यूम बॉइलिंग करेंगे। तो वैक्यूम बॉइलिंग पर ये 450 की जगह पर हो सकता है कि ये 70 डिग्री सेल्सियस पर ही बाहर निकल जाए। समझ आया? समझ आया? तो विल डू दैट वैक्यूम। लाइक
No,
फॉर
sir.
एग्जांपल,
Can you repeat it again?
what I am saying here is that, like for example, a substance A is 450 डिग्री सेल्सियस पर हीट करके बॉयल होता है और सब्सटेंस B इसके अंदर मिला हुआ है। दोनों A एंड B आर मिक्स। A का बॉइलिंग टेम्परेचर है 450 और B का बॉइलिंग टेम्परेचर है 500 डिग्री सेल्सियस। बोथ आर द मिक्सचर्स, दे आर मिक्स टुगेदर। तो आपको पता है कि दो लिक्विड्स को अगर उनका बॉइलिंग टेम्परेचर डिफरेंट होता है तो वी कैन सेपरेट देम इजीली। हम लोग 450 डिग्री टेम्परेचर सेट कर देंगे और 450 डिग्री टेम्परेचर जब तक रहेगा जब तक A बॉइल करता रहेगा, निकलता रहेगा, B उसमें ऐसे ही पड़ा रहेगा। B will not boil because its boiling temperature is 100 degrees, sorry, 500 degrees Celsius. Because of the temperature difference, so we can easily, but we know that if we heat A substance to 4, suppose ऐसी कंडीशन है कि अगर हमने A को 450 पर हीट किया तो B हमारा खराब हो जाएगा क्योंकि वो उतनी हीट नहीं बढ़ रहा है। हालांकि उसके टेम्परेचर, बॉइलिंग टेम्परेचर इज 500 डिग्री सेल्सियस है, लेकिन कुछ जो क्वालिटी हमें चाहिए वो नहीं मिलेगी। लाइक सपोज करो इंजन ऑयल है, इंजन ऑयल के अंदर कुछ मिट्टी पड़ी हुई है, कुछ ऐसी चीज है, तो हम क्या करेंगे कि इंजन ऑयल में से मिट्टी को निकालना है। हमें पता है कि इंजन ऑयल को अगर हमने 500 डिग्री सेल्सियस के टेम्परेचर पर हीट किया तो फिर क्या होगा कि इंजन ऑयल जल जाएगा, खराब हो सकता है। हालांकि पता है कि वो बॉइल कर जाएगा लेकिन उसके अंदर वो उतनी विस्कोसिटी, उतनी चिकनाहटपन नहीं रहेगी दैट इज रिक्वायर्ड फॉर इंजन, that is good for engine. So what we do, we will start boiling it, but we'll boil it in vacuum boiling chamber. जब हम लोग वैक्यूम बॉइलिंग करेंगे तो वो बजाय 500 डिग्री सेल्सियस के इट माइट बॉयल एट 70 डिग्री सेल्सियस पर बॉइल कर जाए। जैसे वाटर 100 डिग्री की जगह पर 20 पर ही बॉइल करने लगा था। समझ आया? सो फिर हमें 500 तक या 450 तक हीट करने की जरूरत नहीं पड़ेगी, फिर हम कम टेम्परेचर पर ही इसको कर सकते हैं। सो दैट इज कॉल्ड, और फिर उसमें से वैक्यूम करके जब हम लोग निकालेंगे तो यू नो दैट whenever something is evaporated then, तो फिर क्या होता है कि उसके अंदर इम्प्योरिटीज तो नीचे रह जाएंगे और जो प्योर मोबिल ऑयल होगा दैट वी यूज इन द कार्स और बाइक्स में वो बाहर आ जाएगा और वी कैन फर्दर फिल्टर कर सकते हैं उसको। तो ये प्रोसेस सबसे अच्छा है कि वैक्यूम बॉइलिंग डिफरेंट डिफरेंट जगह पर यूज की जाती है इन ऑर्डर टू। ओके, आर यू गेटिंग माय पॉइंट? समझ आया?
Yes, sir.
Yes.
सो बॉइलिंग
Sir,
कैन,
are we also going to learn about a conversion of Celsius scale?
या वी विल लर्न इट, इट इज हियर, यू कैन चेक इट, यहाँ पे लिखा है देखिए। ठीक है, मेल्टिंग पॉइंट क्या होता है? Melting point is something that when we change solid into liquids, the temperature at which solid changes into liquid, we call it its melting point, and it should be also 1 atmospheric pressure temperature पर होना चाहिए। Pressure fix है, pressure is fixed, that is 1 atmospheric pressure. क्योंकि आपने अगर 1 atmospheric pressure को change किया, if you change 1 atmospheric pressure, तो the temperature may not fix. Water can boil at 70 degrees Celsius also if you change the pressure. So if you want to keep the if you want to set a standard value for boiling temperature of water, then you must set the standard value for the atmosphere also, for the pressure also, because pressure, on increasing pressure and decreasing the pressure, the temperature, boiling temperature may change. So if you are saying that water can boil at 100 degrees Celsius, you are fixing it that value, so you must fix the atmospheric pressure also. Okay, that it should be 1 atmospheric pressure, because if you vary the atmospheric pressure, then you cannot say that water will boil at 100 degrees Celsius. It might boil at more than 100 and less than 100 also. So simply, if you set that the atmospheric pressure should be 1 atmospheric, then it will boil at 100 degrees Celsius. So that is called boiling point. So in the definition of boiling point, we always heat any substance to convert it into gas. Okay, in the open air, and open air means at 1 atmospheric pressure. Okay, got it? Write down the definition for the melting point also. When you're done, please let me know.
Mm.
Answer.
Done. Okay, what is latent heat of fusion? That we're going to discuss in the next class. Okay. So that's all for today, dear students. We'll meet you in the next class. Thanks for coming.
Thank you, sir.
Thank you.
Bye.
Thank you.
Okay.
Sir.
Okay. Hello, Abubakar, Farhan, Madhavi, Manisha. Everyone is requested to please turn on your camera. Please turn on your camera, everyone. Just a minute. Farhan, you are in which standard?
It's